Welcome to the video tutorial for a lesson called Roofs. It's the first in the series developing algebraic understanding, i.e. generalised number. For all of the lessons there's often a starting cartoon that you can put up in the rooms that people come in, and there might even be a closing cartoon just to kind of reflect upon the thinking. And in this particular lesson it just involves triangular geometry paper, and the start is there is someone on the beach, a little child, drawing a four-sided shape in the sand, and she says she's drawn a flyer, and what could that shape be? So all the pupils do to start is just draw four-sided shapes and name them. Any at all. Some point, now how much you focus on the mathematical language of the shapes is up to you, but it is always good to define, use correct, appropriate language. At some point, someone will draw a shape, a trapezium. And I would always walk around the room at this point and say, I can see that shape out of the window. And we say, I think today we're going to focus on this shape, and it's called a roof. And you can then have a period of time where the pupils draw roofs, and you reinforce what actually is a roof, and you set some limits. That a roof starts here, it goes up here, it goes down here, and it goes along. You could say, do you think this is a roof? No, that's not a roof. That's a roof. Is this a roof? No, that's not a roof. So you're very clear about the shape that you want them to draw. And what happens then is the pupils just draw their own roof shapes. But before you do that, you just say, actually, when we do this, we can give each roof a number code. And this is where the number code comes from. We start here and we go up 1, we can go along 1, we can go down 1, and we can go back along 2. So this number, these four numbers correspond to that shape, and it's a roof. And you ask them, and you can give them some very large sheets of geometry paper to draw as many roofs as they want, big ones, large ones, but to always write the numbers down. So you'll end up with some pupils that will do roof shapes that are like that, some that will do them that are like that. But what you want them to do is very quickly to move away from the drawing shape to writing the numbers down and looking for patterns. And so what you would do is, after you've given them plenty of opportunity to draw, you'd say to them, come and write on the board, come and write your roof numbers, and just leave them. Some of them will be incorrect, leave them. So the pupils just have a go at writing their numbers down. And at some point you'll physically step back and say, are all of these roofs? Do we think they're all roofs? And they might check them, and some might come up and say, well, I don't think that one's a roof. I think that one's a roof. I think that one's a roof. Oh, that one's not a roof. Because what this lesson is focusing on in thinking terms is, at about end of year 6, beginning of year 7, children find it very hard to hold two correct rules in their head at the same time. And some children will pick one of the rules that makes the trapezium, and some children will pick the other one. And you want them to make them be aware that in this situation there are two rules as part of the condition. So you go around and think, well, that's a roof. Well, that one's a roof. And so on and so on. Oh, I'm not so sure about. Well, that one's not a roof. You say, well, hang on, I've drawn another couple of roofs. I'm interested in what numbers always work for a roof. Have you spotted any patterns in these numbers? I mean, by this point you might have 50 on the board. It's brilliant, and they can rub them off and write on them. You can be as active as you want, but getting them to check the numbers. Say, okay, if these numbers work, what have they got in common? Can you write down any rules? So with your partner, you can have pairs to fours at this point. With your partner, write down a rule that you think makes a roof. And so what you would do is, you give them time to agree it, you would write down every rule. You might say, oh, John's group said the sides are the same. So here's group. They say the last number is the biggest, and so on. So you write down all of their rules. It doesn't matter if they're right or wrong. If they say things like all have even numbers, the last one's the biggest, it doesn't really matter. They're writing down their rules. They've got ownership of this. You're asking them to spot patterns. You're not saying which is the right answer. And so once they've got all their rules here, you ask them to vote which one is the best. So they're voting on which they think is the best single rule. Some of them might realise you need two of them, but most of them, because they won't be thinking, they'll just think, well, I like this one. And usually that one gets the most votes, or that one gets the most votes, depending on your class. Or there might be a bit of a conflict. So this is the time when you have the discussion that, well, actually, one rule doesn't work. Because if they agree this one, the sides are the same. You say, okay, 4, 6, 4, 11. The sides are the same, so you can relate it to the shape. The sides are the same. That's a roof, draw it. And a lot of them will want to draw it and go, oh, it's not a roof, it's too long. And they'll say, oh, you've got to change that number to 10. It's quite hard to explain how rich these discussions are when you're forcing children to make decisions and to justify themselves. Normally it's just about being right or correct, and the children can really feel uncertain when you're saying, well, which do you think's the best one? Which is it? Eventually, after a period of discussion, you'll get to a stage where they will agree, but you need two rules, sir. You say, okay, what are the two rules? The first add the third equals the last. No, sorry, the first add the third, or the first add the second equals the last. The first and the third are the same. So you now have two rules that make up a roof. All right? So then you go through a period of, and they quite like this bit, and it's quite important to go through these stages. Because what you don't want is to say, right, okay, give me a number, 10 and 2, 10 and 12. Oh, I think we can use letters now. No, children from a very young age use letters incorrectly. They use the letters as part of a substitution. So they've been familiar with P plus 6 equals 14, being able to solve that. And they think that's algebra. It isn't. That's just a substitution. So what we're asking them to do here is build up till the numbers get so big that they don't make any sense to them. They could be anything. So you go through a period of time where the children will give you bigger and bigger numbers. And they love it because they just shout out and chant that they get the right answer. 17 and 20, 17 and 37. And you go bigger and bigger and bigger till you take up a full sheet of the paper. 14 and 8, 14 and 22. 160, 100 and 160. And you build up and 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 build up till it gets so big, well, they say, sir, here's 1,000,000 and 1,000. And I'll get the point now because I'm deliberately not very neat. I'll say, oh, I've run out of space. Is there any way I can carry this pattern on so I don't run out of space? How can I keep it going? How can I make sure that I can keep on the... Because it works for any number, doesn't it? Okay, how can we keep the pattern going? And I would give them 5 minutes to have a discussion in the group about how to keep the pattern going. And they'll say things like write smaller, use a thinner pen, do a code. Okay, let's do a code for 1,000,000 and 1,000. And this is an element of kind of sleight of hand. So if they're focusing on the 1,000,000 and the 1,000, so on, I could say, well, let's just do M for 1,000,000 and T for 1,000. What comes next if the pattern works? Oh, so it's got to be M. But what comes next? That's the same as that. Add that, M plus T. Well, does that work? Oh, could we use a circle and a square? Yeah, what comes next? A circle plus a square. Could we use a cat and a little rabbit? That's not a rabbit, sorry, I'm rubbish at drawing. And you say, yeah, we could. So, oh, that's interesting. So we can carry this pattern on. I tell you what, why don't we just use the first letters of the alphabet? So you do A, B, A, And then wait, because some will say A plus B, some will say C, and that's a moment for pausing, to let them debate the difference that's emerged in the class. These lessons are about, many of these lessons are about reading your class and pausing at that moment when there's a bit of dilemma, a bit of conflict, a bit of challenge, because you are challenging them to go somewhere where logically they might not be able to go. In fact, you ask, maths is about humans' endeavour to make sense of the world, and it's not been easy. Zero was invented a few hundred years ago, so before it was invented, we didn't have it. So you've got to put them in that situation where you're really challenging, but you're reading the class. And if there's a conflict, you step back and let them discuss. And this is a key point where they say it's got to be A plus B because that's following the rule. So there is a cartoon to illustrate. There is a cartoon you can put it at this point, which you'll see in the resources that gets them to think about what's going on. But at this point, I might say to them, well, what could this A be? What could this A be in numbers? Like, could it be this? It could be anything, sir. So how come we've got a letter that can stand for anything? And usually at this point, I give them the label that when a letter stands for a number, it can be a number holder or a number carrier or a number variable. It depends on the ability of the class. So a number variable is the one that you'd use for a more able group. But for many pupils, the idea of a letter being a number holder or a number carrier is a really interesting idea because they've never thought about that. They've come across algebra as 6 plus A equals 47. That's what they think algebra is. They think it's some kind of code, some kind of one-to-one correspondence. Well, here, that can be anything. It can be any value. And one colleague, when he did a plenary at the end of the lesson, he asked his class, why is it useful to have number carriers to stand for numbers? And 6 of them said it helps to find out an unknown number. 4 of them said it stops writing lots of numbers. 1 said it's algebra. 5 says it represents numbers you don't know. 2 of them said it represents a number, it stops confusion. And 3 said you can make it shorter and easier. But you want to give them an opportunity of saying, why are these letters a useful symbol, a useful tool within mathematics? How can that letter stand for any number at all? What does that make you think about? Can you think of anything else like that? You give them a chance to reflect upon. It's not the answer, such as 41. It's not the answer. It's this whole concept that you want them to think about. You want to say, well, we've got these letters that stand for numbers. They're number holders and number carriers. And it's often in the past when you've got some tiny little year 7 child that never takes the rucksack off. I've usually got them up at the front of the class at this point and said, he's a number holder, he's a number carrier. What numbers could he be carrying? Why is that a good idea to use in maths? And that lesson's called Roofs. All you really need is triangular dotted paper, but I'm sure you'll find it's a really useful introduction at the start of year 7 to generalised number and algebraic understanding.